Okay, this is lesson 5, cosine law with angles for my essential math class. And before we actually hit the lesson, a little preamble here. A little calculator fun. What should this be? If I run that through my calculator, what should I get? Don't all answer at once. That should be 1, shouldn't it? Clearly the top is 7, and 7 divided by itself is 1. But check this out. If I bring up my calculator, let me clear all that, and I punch it in exactly the way I'm reading it. 5 plus 2 divided by 7. Gee, that's a funny looking 1. 5.2857. Clearly something's wrong. What have I done wrong? Yeah, the calculator doesn't understand that the 5 plus 2 has to happen first. It follows BEDMAS. BEDMAS says divides happen before plus. So how do I get around that? Well, it's actually a pretty easy workaround. I just have to put the 5 plus 2 in brackets. Now, some of you out there might have a fancy calculator that actually has like a numerator and a denominator button, in which case, great, you can use that. But for most of us, we will need brackets to accomplish what is really obvious when we look at it on a piece of paper, that clearly I have to do the top first. No difference in this one, too. Suppose I had 2 times 3 divided by 6. Once again, clearly that should be 6 over 6, which is 1. But if I take my calculator and I go oh, hang on, I meant to do this upside down. Can I have a mulligan on that? That's what I meant to do. 6 divided by 2 times 3, which is 1. If I punch that on the calculator, and I just do it the way I say it, 6 divided by 2 times 3, without a bracket, it thinks that I want this. How do I tell the calculator, no, dummy, I want this, I don't want that? I do it with a bracket. Now, this bracket here is just kind of me being, lazy and not wanting to write a times symbol, so I use brackets. When I actually want to punch this on a calculator, when I want the calculator to do exactly that, I have to go 6 divided by, and then open a bracket, 2 times 3, and then it knows that I meant this and not that. Does the logic of that make sense to you? And you can kind of see maybe why we're heading this way if you take a look at the formula on the page in front of you that's coming up. It's got stuff on the top and it's got stuff on the bottom. One last refresher. Why do we need this formula again? Well, we already saw that we can do sine law if we have this kind of triangle where I've given you an angle and, say, a side and another side, like that. Angle side side, we called it. If I give you angle side side, you can use sine law. If I give you any 2 angles, like those 2 angles and the side in between them, I'd call that angle side angle. Get it? Because the side's between the 2 angles. Or if I gave you angle angle side. Now that one's a little harder because I'd have to maybe do a 180 rule first. But it doesn't matter. All of these cases are sine law. So when do I need cosine law again? Oh yeah. What if I give you an angle that's between 2 sides? Then you're stuck. No 180 trick can help you. Sine law doesn't work for this triangle, so we have to use the cosine law. So that's for what we call side angle side. All right, there are 2 things we haven't explored yet. What if I gave you just all angles? Well, that's not solvable because think about it. If I don't have any sides, I have no idea how big the triangle is. Right? Like I could make you a 30, 60, 90 triangle that's this big or this big. And all the angles are the same. So there's no such thing as solving angle, angle, angle. Meh, I can't solve that. But what about side, side, side? What if I tell you all 3 sides and I don't tell you any angles? Can you figure out what the missing angles are? And the answer is yes, but you have to use the cosine law. Now the cosine law looked like this. Now I know some of you guys, you signed up for this course because algebra is not your friend. But I'm just going to do algebra for a minute. Just a minute here. Here is one version of the cosine law that we were just using yesterday. What if I wanted to isolate this part? Know what I mean by isolate? It means use my algebra skills to make that all by itself. What would I do? Well, the first thing I do is I take these two guys, and right now they're plus on this side of the equation. So if I move them to the other side, they become minuses. There. Now the equation looks like that. Now I got to get rid of this stuff. What is this stuff doing to cosine of A? It's multiplying it. What's the opposite of multiplying? So I'm going to divide both sides of the equation by this part. So now I'm going to get a squared minus b squared minus c squared over negative 2bc equals cos A. Now you'll notice that isn't quite the formula we were looking at a minute ago either. You know why? It's got too darn many negatives in it. You give me a formula with that many minuses, I'm bound to goof one up and miss one. So we have a way to make that a little easier to play with. What we can do is, do you remember from grade 10 MEAP, do you remember factoring? I'm going to factor a negative 1 out of the top. So that means this b squared that is negative is now a positive. This c squared that's a negative is now a positive. And this a squared that's a positive is now a negative. And then I'm going to factor a negative 1 out of the bottom too. And that's where we are going to get our new formula. I'm going to write it the other way. I'm going to write it backwards. I'll put this one on this side now. And what happens when you divide a number by itself? What's negative 1 divided by negative 1? What's anything divided by itself? Oh, it's not 0. Yeah, it's 1. So those two things cancel and they leave behind 1. So that means that I have b squared plus c squared minus a squared all over 2bc. Now they kind of, you'll notice in your notes, let's go back to the notes now. Oh, where are they? Oh no, there we go. Notice in the notes, they've left the brackets on the bottom like I just did. And they didn't bother with a bracket on top, but I know there's a bracket there. Kind of like in that little exercise we just did with the calculator. If I don't put that in a bracket when I punch it in, it's not going to give me the right answer. Because it won't know, the calculator won't know to do this add and subtract before it divides. So even though there's no bracket there, there's an invisible implied bracket there. So, okay. And then on the bottom we actually do have the formula has the bracket on it. All right, for example 1, we're going to try to write small here so we can do all of example 1. What do I mean by all of example 1? Well, I'd like to know all 3 angles. I have all 3 sides, I'd like to know all 3 angles. Let's do angle A first. So we're going to use this version of the formula. The cosine of angle A is b squared plus c squared minus a squared. Do try to write small because we're going to try to fit 3 calculations in here. All over 2 times b times c in a bracket. Okay, so first step is I have to figure out which side's which. Which side is A? The 22, the 30, or the 18? The 18's A, because it's across from A. Which one's C? The 30, and that means the 22 is the B. So I have to put the right things in the right places. Notice it doesn't really matter which one's B and C because you're adding them, but remember, subtract has to be in a certain order, right? Just logically speaking, 3 minus 2 is not the same number as 2 minus 3. Right? Those aren't the same number. So it matters which one is side A. B and C, if they didn't tell me which angle was B and which angle was C, it really wouldn't matter to me. Okay, we have a question. Not necessarily. You're used to that. The question was, is C always going to be the biggest side? You're used to that from junior high Pythagoras and what you saw in SOHCAHTOA in MEAP, but this just happens to be what it is. In fact, we'll do an example. There's only 3 examples on this page. I'll make up a 4th example where we don't even use A, B, C. We'll see if we can figure out the formula for 3 different letters. Okay? The letters kind of don't matter that much. But what does matter is if this is angle A, side A has to go here. It has to be the one that's being minused. So it's going to be 22 squared plus 30 squared minus 18 squared. And all that's divided by 2. Okay, I don't want to use x's. I hate using x's for multiply when especially when things get complicated like this, because I trick my head into thinking it's a variable. So I'll use a dot for multiply. Are you guys okay with that? 2 times 22 times 30. There we go. Now everybody take out your calculators and let's punch this together. You have to be careful punching this in. Okay, so calculator, where are you? Oh, there you are. Oops. Now look at that. Now it kicked me out of my program. There we are. Okay, calculator on. There we go. And open a bracket. If you've never used your brackets before, they work just like you say them and the way you write them down. You start by opening a bracket. So open a bracket. 22 squared plus 30 squared minus 18 squared. Close the bracket. That just tells the calculator, do this calculation first, then divide. Then open a bracket. 2 times 22 times 30. Close my bracket and hit equals. And we got ourselves a decimal. Remember, when we're doing cosine, that's to be expected. And remember, that's not how big the angle is. That's how good my memory is. I forgot the decimal already. 0.803. It looks like it's 0.803 and then 0303, so the 03 is repeating. 0.803 repeating. There, I'll just write the repeating. Saves me work. That's not what you got? Okay, then did you use brackets? Are you sure? There's no way it could possibly be 1 point something. How do I know that? Cosine and sine values, remember, can't be bigger than 1 or smaller than -1. Some of you who have taken pre-cal remember that from your unit circle. Also, just the logic of it. Isn't cosine opposite, or sorry, no it's not. Isn't cosine adjacent over hypotenuse? Hypotenuse has to be bigger. That fraction can't ever be more than 1. So nope, try it again. Did it work this time? Okay. Remember, I want you, do not punch this in pieces. One big calculation. That scientific calculator of yours should be able to handle much more complicated button punches than this. I see no value in figuring out this number, then this number, then this number, then figuring out the top number, then figuring out the bottom number, and then repunching everything. Blech. Waste of time. Okay, anybody else not get that decimal yet? Now, remember, that's a small angle, but it's definitely bigger than 0.8 degrees. We're not done yet. What's our last step again? What do we call it? Inverse. Good, you remember it. It's called inverse cosine. We write it, that's the symbol we write for it. And remember, I don't repunch decimals, and neither should you. You should go inverse cosine, and some of you have an answer button. Some of you can just hit equals and it'll be there, and some of you didn't even need to hit that. As soon as you hit inverse cos, whatever was on the screen, boom, becomes this number here. 36 point, okay, I'm going to round that to 5/8 degrees. And there we go. We just did angle A. I want to do angle C next, because angle C is going to have one little thing about it that confuses people sometimes. We'll talk about it. But okay, let's see. Let's see if we can get the formula without peeking at it. Now you're looking at the page, so you can see it's just up on the left. But I'm going to actually see if I can figure out the formula all for myself. Cosine of angle C. What do I know about this formula? What's the pattern to it? Oh yeah, the side across from the angle I'm looking for is the minus. So the other two must be the pluses. Does that make sense when you think about it? Divided by, and what's the pattern to this formula? Oh yeah, the one that got minused isn't on the bottom. So there it is. Now let's put our numbers in. Cosine of angle C is 18 squared plus 22 squared minus 30 squared all over 2 times 8. Oh, hang on, I like using dots. 2 times 18 times 22. And punch buttons and tell me what, okay, I'm just going to move up to here because I'm kind of out of room. Tell me what the cosine of C is going to equal. This one's interesting. Yeah, I heard an ooh from the crowd. Not the kind of number you were expecting. And very often people go, oh, I must have punched something wrong. Because look what happens. Open a bracket, 18 squared plus 22 squared minus 30 squared, close bracket, divide, open the bottom bracket, 2 times 18 times 22, close the bracket for the bottom. I got a negative. Oh, that looked weird, didn't it? We haven't seen a negative number in anything we've done so far in sine law or cosine law. But you know what? That's not wrong. I didn't make a mistake. This is negative 0.16. Is it 1/6 repeating? Oh, it's 1, then 1/6 repeating. There, let's write that better. That's what we call in math a partially repeating decimal. Right? The first digit or two doesn't have to repeat, but then after that it repeats. 1/6 is like that, right? It's 0.1, then 6 repeating. Anyway, what's the deal with the negative? You know what that negative's telling me? It's probably telling me something that you could tell from the picture, assuming the picture is reasonably close to scale. What kind of an angle is C? Begins with the letter O. It's an obtuse angle. Cosines of obtuse angles turn out negative. Guys who came from pre-cal know why that is. Remember the unit circle? For those of you who have never seen a pre-cal course, you can just tune out for a second. But I just want to remind folks, if I put a triangle over here, then cosine is adjacent and hypotenuse. That's a positive line. But if I put a triangle, the same triangle even, right over here, that line is now in the negative x direction. So the adjacent over hypotenuse is a negative number. Cosines can be negative when your angle is bigger than 90 degrees. So that's not unexpected that it should turn out negative. It actually tells me something. It tells me, oh, I'm going to get an obtuse angle here. Let's see if that's true. Angle C should be the inverse cos of negative 0.116 repeating. And again, I don't repunch that. I go inverse cosine of my answer. 96.67. That's bigger than 90. It was right. We were right. It's obtuse. What comes after the 7? A 0. So it's 6, 7 degrees. Okay, now, did I need to use cosine law to find that angle? The answer is no. Because think about it. Once I figured out what angle A was, well, then I know A and side A. I could have used sine law, but I decided not to. Now we're back. There. Okay, so the point I was making was that we could have used sine law if we'd have wanted to. But you know why I didn't? It's like, why wouldn't you use sine law? It's so much easier, less buttons to punch. I like the idea that I could find these two answers or find this new answer without having to use the first answer. Sometimes that's unavoidable. Like in your homework, there was no way to do this problem without there was no way to find this line without finding that line and then using that number. But if you can avoid using something you calculated and just using givens, that's not a bad idea to do that. That way, if you made a little mistake on the first answer, you don't doom your second answer to be wrong too. Having said that, I have my patience, and so do you. Now that I know two angles, do I really want to run through cosine law again? No. Once you know two angles, how are you going to find the third? You're just going to use the 180 rule, correct? So that's what I'm going to do. So angle B is going to be 180 minus these two guys. 96.67 plus, what was the other angle again? 36.58. And I hope you were writing small. I had to go over the side of the page because I'm writing so big. And so I'd go 180 minus, open a bracket, and, well, actually the last answer I had was that number, so I can just use my answer button again. But then I got to think back to, what was that? 36.58 plus 36.58. And so my last angle is 46.75. There. Triangle solved. All three angles in the house. All right. For the next two examples, they only want us to find one angle, a specific angle. I'll do example 2 with you, and then you're going to try example 3 on your own. So here's example 2. I would like angle A, please. Now, I guess technically, we like angles to be capital letters. I don't know what book they stole this from, where they use a small letter for A, but we'll think of that as angle A, and that would make this side A. Does it matter which one I call B and C? And the answer is not really. It doesn't matter. So I'll call this one B, and I'll call this one C, and here's my formula again. So let's see if we can remember it without peeking. Okay, I know that A has to be subtracted, which means the B's and C's are added, and then the bottom is the ones that I didn't subtract, B and C. It always works that way. All right, we plug in numbers. So the B is 9, the C is 12, the A is 5, and the cosine of angle A is, moving right along, open a bracket. I kind of know what 9 squared is. Are you okay if I just type 81? I also kind of know that 12 is 144 when you square it, and 5 squared is 25. Saves button punching if you know a little bit of mental math. Divided by, open another bracket, and I happen to not know what 18 times 12 is, so I'll actually just 2 times 9 is 18, so 18 times 12. Close my bracket equals 0.925, 925, 925. Oh, look at that. It's 0.925 squared, or not squared, repeating. Isn't that what you get? Okay, let's try it again. You know what? This time I won't do any mental math shortcuts. I'll try it again. Watch me. Ready? 9 squared. First of all, did you open a bracket? Then 9 squared plus 12 squared minus 5 squared. Then you have to close that bracket, right? Because otherwise the calculator doesn't know to do that calculation first. Divide by. Now open a bracket for the bottom. 2 times 9, you found your mistake, times 12, close the bracket, equals. Somebody asked me this morning, how do you know it has to be a repeating decimal? I said, well, it doesn't have to be repeating. It could be terminating, but it has to be one or the other, because there's no square roots here. There's nothing irrational. Anytime you have an integer divided by an integer, you get an answer in decimals that either ends or repeats somewhere. Sometimes the repeating pattern is so long that you can't even see it on your calculator, but it'll be there eventually. Anyway, that's just a digression. Let's get back to finding angle A. Are you okay if I kind of save some time here and just jump right to angle A? We know it's always going to be the same. It's always that inverse cos. Save a bit of time. So inverse cos my answer, boom, 22.19 degrees. Okay, now that you've seen me use this formula 3 times, let's see if you can do it. I'll pause the video. Guys who are doing this at home, please try example 3, and then turn the video on when you've got an answer, and we'll see if you've got the right answer. We're back. Okay, let's see how this went. Once again, I was telling the people in class while we were paused that this was obviously stolen from a textbook that doesn't follow our little rule that most textbooks follow and make the angle a capital letter. So we are looking for angle B, which means the B is what's being subtracted and the A and the C are being plussed. And on the bottom, it's A and C. All right, so the cosine of angle B is, now does it matter? This one has to be B. It doesn't matter which one's A. I'll make this one A and this one C. If you did it the other way, we'll get the same answer. At least we should. So 36 squared plus 38 squared minus 33 squared all over 2 times 36 times 38. And now let's show you how to punch buttons in case you need one more reminder on that. Come on, come on. Calculator. Oops. Come back. There you are. On. Clear all that. Okay, open a bracket. 36 squared plus 38 squared minus 33 squared. close the bracket, divide by, open another bracket. 2 times 36 times 38. Close my bracket and hit equals. I seem to remember getting that decimal this morning. Here's what I was talking about a minute ago. That repeats somewhere, but I can't even tell. Like, I can't see where a repeat starts, so it must kind of start after that. Anyway, 0.603 and change. Blah blah blah. But that number is not really the number I want. I want the inverse sine of that number. Inverse cosine of that number. Sorry. Oops. Oh, wrong button. Second function cos inverse. There we go. Ta-da! 52.88 degrees. All agreed? All right. You have mastered button punching. Okay. You have some room under here. I'm going to make up a fourth example because this hasn't happened in our notes yet. It didn't happen in sine law either. But there's questions like this in your homework, and you never know. We might throw one on the test next week. What if I don't give you a picture? What if I say, so we'll call this example 4. Jot this down. If you write big, you could put it on loose leaf instead of on the paper. But if you have room at the bottom and you write small, write on the page. Example 4. Find angle P in triangle PQR if side P, so that's a lowercase, equals, say, 10 centimeters. And we'll say, comma, Q is, we'll say, 6 centimeters, and R is 5 centimeters. Okay, so now you're going to have to make the sketch from the description of the triangle. We haven't made you do that yet this year. It's not a big deal. You just kind of have to go, okay, well, I want a triangle. I can tell from the numbers that it's not equilateral. It's not right. Otherwise, why would it be, well, I guess it could be a right triangle, but I kind of know from Pythagoras that it's not. 5 squared plus 6 squared does not equal 10 squared. 25 plus 36 is not 100, so it's not a right triangle. So it's I guess a scalene, and it's either obtuse or acute. I don't know that I care that much if I get that wrong, but I'm going to try. Let's see. If this side here is 5, and then the side next to it's got to be twice as long. There's the 10. So this is R is 5, P is 10. Then 6 might be something like that. Q equals 6. Just a little bit bigger than that one, but nowhere near as big as that one. Okay, that's probably off. That's not, obviously not to scale. Now that I look at it, my bottom side isn't twice as big as my left side. But good enough. It doesn't have to reflect reality. It only has to represent it. And I am looking for which one? The angle at the top. So we will definitely get you to do this at least a couple times in the homework. So I will say cosine of angle P is, and okay, what's the formula going to look like? Oh no, it's not A, B, and C. Yeah, I know I did that on purpose. So what is it? Yeah, you're right. The P squared has to be the subtract, so the other two have to be the adds. That is correct. Good work. And then what's the bottom? Okay, but let's use letters first. It's R and Q, or Q and R, doesn't matter. Correct. Does the logic of how I knew that make sense to you? Because once you understand how the formula behaves, who cares what letters you put on it? You can go with Greek letters if you want and have sides and angles, alpha, beta, gamma. Lots of textbooks do that. It's like, English alphabet. So this century. Let's go classic. All right, so cosine, yeah, retro alphabet. Cosine of angle P is 5 squared plus 6 squared minus 10 squared all over 2 times 5 times 6. And cosine of angle P is, let me move that over, turn it on. I don't know why it turns off on me every time I shrink it. It shouldn't do that. Yeah, you get what you pay for this app, I guess. Open a bracket, 5 squared plus 6 squared minus 10 squared, close my bracket, divide by, open my brackets, 2 times 5 times 6. Close brackets. Oh, hang on, did I do something wrong? Ooh, that one's terminating. And it's negative, and what's that telling me? We're going to get an obtuse angle, correct. So it's negative 0.65. And I would like the inverse cosine of that. Inverse cosine of my answer. Oh, that didn't work. Erase, erase, erase. Inverse cosine of my answer, not my entry. And there we go. Angle P is 130.54 degrees. And there it is. I'll leave that up for you for a minute if you're still catching up to me. Everybody who's caught up to me, you are ready to start your homework. Yay!